Yeah, good morning, Hannah. Thanks for hosting us. So, yeah, let me share the screen. So, can you see the poster? So, yeah. So, hi everyone. My name is Giuseppe Degan Di Dieco, and I'm a second year PhD student at the University of Bristol, while at the Turing I'm embarked on a machine learning journey. So, today, my poster presentation today is for machine learning for forecasting damages to riverine bridges hit by floods. So damages due to induced to bridges by flood hazard are typically estimated via damage curves, which you can see which link the discharge to the probability of failure. However, a few damage curves exist in the literature for us that to account for flood-induced damages to bridges, thus impairing flood risk assessments at the network level. The first step for developing damage models is the characterization of the various structures within a portfolio. So, as a flood-prone case study, we analyzed the bridge dataset of Devon County Council in the southwest of England, and 281 riverine bridges were identified, as you can see here, and three main types of riverine bridges were identified for which we are going to develop these damage curves. What happens is that damage curves are computationally expensive to derive via structural reliability analysis. Just think that one analysis needs 2 weeks. So our research will investigate whether machine learning model can successfully be applied to artificially derive damage curves. As a proof of concept, our research is focusing now on masonry arch bridges. Recently, a study was published on the artificial derivation of a damage curves for a riverine bridge only for a single structure. And from the second graph, we can see that the authentic model is well approximated by the machine learning model. Therefore, what we did, we reviewed the literature and we found only 3 damage curves for masonry arch bridges, and these curves are going to be artificially derived. In particular, you can see that the curves are affected by the number of spans of a bridge, which means that this attribute is one of the attributes to classify bridges at risk of flooding. In particular, you can see that these curves shifts toward the left and the right, whether the number of spans increases or decreases. So what happens is that, in conclusion, since machine learning models have been successfully applied for the derivation of damage curve of a single structure, our main expectation will be to use these models to artificially derive damage curves for thousands of structures. And this is the results of this. So we can do, by comparing all these curves all together, we could, we could derive bridge classes with less computational efforts, and therefore identifying which are the attributes to classify bridges. The proposed classification of riverine bridges will then allow the flood risk assessment of a transportation network accounting both for roads and bridges vulnerability. So please do get in touch if you have any questions and suggestions. So I will be very happy to hear from you and to test machine learning models together. Thanks. Oh, my pleasure.